For the calculation of marginal product, we also use using another formula here. Marginal product of labor, it is equal to TPL minus TPL minus 1. Look here, marginal product of variable factor equal to total product of variable factor minus total product of variable factor minus 1. Here this indicates the number of units of labor, its total product, and this formula indicates TPL minus 1. The previous units labor and its total product. Okay. It is considered as the another formula of calculation of marginal product of labor. For example, look here, 1 unit of labor, it produced 10 units of total product. 2 units of labor, it produces 24 units of total product. Now, calculation of marginal product. What is the marginal product of second unit of labor? Look here, MP2, we write here in the place of L, write 2. It means second units of second units marginal product. It is equal to total product of second unit. Total product of second unit is 24, right? Minus total product of 2 minus 1. 2 minus 1 means first unit. The first unit total product is 10. That is why we called as it is the previous unit. The L minus 1 indicates the previous unit's total product. So, it is 10. So, 24 minus 10 equal to 14. It is a marginal product. So, this is another formula to calculate a marginal product of labor. The next concept, the law of diminishing marginal product. It is also referred as law of variable proportion. Remember the next concept, the law of diminishing marginal product. This law indicates short run production analysis. We know that in the short run at least one factor is fixed, other factors are variable. In this concept, the marginal product of the factor input initially rises with its employment level. Remember, marginal product of the factor input initially rises with its employment level, but later after a certain level of employment, marginal product starts falling. This is the concept of law of diminishing marginal product. Remember, with increasing units of variable factor, increasing the units of variable factor, marginal product initially increases. After a certain level of employment of labor, marginal product starts falling. Initially marginal product rising, later marginal product is falling. It is called law of diminishing marginal product or the law of variable proportion. We explain this concept with the help of a table and diagram. For example, in the table we write units of labor, then we write total product, then we write average product, then we write marginal product. For example, units of labor 0, In our earlier example, we states that units of labor 0, so total product is 0, there is no marginal product and average product. If labor increases 1 unit, now we write the total product is 10, marginal average product is also 10 and marginal product also 10. We write here L, L, L because total product of variable factor, average product of variable factor and marginal product of variable factor, but in our case variable factor is labor. Next, 2 units of labor, total product increases to 24, average product is 12 and marginal product is 14. Then we write third units of labor, total product increases to 40. Now average product means TP by L, 40 by 3. We get the answer is here 13.33 and marginal product 40 minus 24, 16. Then the 4 units of labor, now total product is increases to 50, average product 50 divided by 4, 12.5. Then marginal product 50 minus 40 is 10. Then 50 units of labor, total product increases to 56. Now average product is 11.2 and the marginal product is 56 minus 50 is 16. The 6 units of labor, total product increases to 57. 57 divided by 6, 9.5. 57 minus 56, 1. This table indicates or related to our concept, the law of diminishing marginal product. I stated here one meaning. Marginal product initially rises with its employment level. After a certain point, the employment level, it means after a certain point of employment level, marginal product starts falling. Look here, initially marginal product increases. After a certain level, the employment of variable factor, the marginal product is falling. So this concept is called law of diminishing marginal product. And law of diminishing marginal product, the short run production analysis. In the short run, at least one factor is constant or fixed and other factor is a variable. So continuously changing the variable factors with the fixed factor. Initially marginal product increases. After a certain point, marginal product starts falling. We explain this concept with the help of a diagram. In the diagram, x-axis and y-axis. In x-axis we represent TP, total product. Sorry, in y-axis we represent TP. Then we represent MP and we represent AP. In x-axis or in horizontal axis we represent units of labor. Units of labor. 0 unit of labor, output total product is 0. Remember, total product it starts from 0. Total product curve it starts from 0. If you write here units of labor up to 6, 1, 2, 3, 4, 5, 6. Okay, take here the correct scale measurement. Okay, 1, 2, 3, 4, 5, 6 units of labor. This axis indicates units of total product, average product and marginal product. So right, start with the first 1 centimeter indicates 10 units, 20 units, 30 units, 40 units, 50 units and 60 units. It means total product or average product of the value, the scale, the y-axis indicates 10 to 60 units. When zero level of input, it means input, it means labor used 0, total product also 0. So here the initial or point of total product. Total product is continuously increases, reaches maximum. This curve indicates a total product of labor or total product of variable factor. So continuously use of the labor, total product is continuously increasing. Average product and marginal product starts from first unit of labor. So first units of labor, initially we know that marginal product is continuously increases, average product also continuously increases. So now we draw the marginal product curve and average product curve. So first units of labor, then average marginal product is increases, reaches maximum, thereafter marginal product starts falling and it become 1. When 6 units of labor, marginal products become 1. Then average product also from the first unit, it starts increasing, then it reaches to maximum, thereafter it starts, after that it starts falling. This curve indicates marginal product of labor and this curve indicates average product of labor. So remember, from this point both AP and MP starts. It means first units of labor, the value of AP and value of MP are same. Then MP continuously increasing with the increasing the variable factor, it reaches a maximum, thereafter marginal product starts falling. Average product also initially increases, then reaches maximum, thereafter average product is falling. So this tendency indicates law of diminishing marginal product. This tendency, it means increasing, initially increasing, thereafter a certain point a marginal product starts falling, it indicates the law of diminishing marginal product. And it is also called as law of variable proportion. Total product continuously increases, but the rate of increasing is not constant. Total product is continuously increases, but the rate of increasing in total product is not constant. Changes in, it means the rate of total product is indicated by marginal product. It means changes in total product we consider as a marginal product. And this law I already mentioned, this law is also referred law of variable proportion. It means we states here one point, factor proportion. Factor proportion means the ratio in which two inputs combination is used and producing the output. Factor proportion means the ratio in which two inputs combinations are used to producing the output. And remember, out of the two inputs combination, one input is fixed and another input is variable. Continuously the variable, increasing the variable factor with the fixed input, total product is changing. It means the factor proportion changes with the changing the variable factor. Initially, we know that initially variable factor increases with the fixed factor. Initially the variable factor increases with the fixed factor. The use of variable factor is increases, that's why marginal product is increasing. After a certain level or after a certain point, then variable factor become too crowded. Now marginal product starts falling. Initially, just observe the table. Initially total product is increases 10 to 24, 24 to 40. It means the proportionate rate of variable factor is more than fixed factor. That's why total product is increases at increasing rate. Later total product increases at a diminishing rate. Total product increases at we consider as at increasing rate. After that total product is increasing at a diminishing rate. So diminishing marginal product, the law of diminishing marginal product. And in this diagram we also states some other points. Total product curve continuously increases with the increasing the variable factor. Once this curve, it means total product reaches the maximum, thereafter total product starts falling. And remember, when total product curve starts falling, it means in that time marginal product become negative. Okay. Up to marginal product's value positive, up to that point total product continuously increasing. Total product continuously increases when marginal product its value is positive. When marginal product is 0, total product is maximum. When marginal product is 0, total product is maximum. When marginal products its value negative, total product starts falling. It means the use of the variable factor is overcrowded. It is too crowded. That's why total products is not increasing. Total product starts falling. And here we also another observation. Marginal product and average product both are increasing in the initial stage. In the initial stage both marginal product and average product are increasing. Later both average product and marginal products are falling. But remember, first marginal product starts falling, then average product is falling. When average product is rising, marginal product also rising. Now the value of marginal product is greater than average product. When marginal product starts falling, now average product is continuously increasing. When average product is maximum, here the value of AP and MP are equal. The value of average product and marginal products are equal when average product is maximum. After that average product starts falling, marginal products also starts falling. Remember, when average product is falling, marginal product also falling, but now marginal product is less than average product. Okay. These are the explanation related with the law of diminishing marginal product. Remember, first you should write the meaning of diminishing marginal product. Then remember this table. On the base of the table, we draw the diagram. Then its explanation. And very important concept is here, factor proportion. On the base of the explanation of the factor proportion, we easily understood the concept of diminishing marginal product. And the factor proportion, it is a ratio in which two inputs combination are used to produce the output. But remember, out of that two inputs combination, one input is fixed and another one input is variable. Increasing that variable factor, marginal product increases initially, later marginal product starts falling or diminishing. So, it is a law of diminishing marginal product. The concept of shapes of total product, average product and marginal product. Shapes of total product, average product and marginal product. Shapes of TP, shapes of TP, total product. The first one is shapes of total product, then average product and marginal product. First we draw the shape of TP, total product of labor or total product of variable factor. Total product, it starts from origin, the curve starts from the origin and continuously it is rising, thereafter it starts falling. Total product starts from the origin, it continuously increasing, reaches maximum, thereafter total product starts falling. Look here, in this diagram we write in y axis output and in x axis we write units of variable factor. In our example it is labor. So, total product is continuously increases and then reaches maximum, thereafter it starts falling. TPL indicates total product of labor curve. Suppose a firm it is used L units of labor, what is the output level or what is total product? So, total product is Q1. Q1 is output level with the use of units of variable factor or labor. So, a firm uses L units of labor, it produces Q1 units of output. This diagram indicates the shape of TP. TP curve continuously starts from the origin, continuously increases, reaches maximum, thereafter total product curve starts falling. Then, what is the shape of AP and MP? Look here, the shape of AP and MP. Here write AP and MP. In y axis we represent, again we write here output or write here AP and MP. So, easily we should write here AP and MP. And in y x axis we represent again labor. X axis represent labor. X axis represent labor. Now, the shape of AP and MP. Look here, the shape of MP initially rising, reaches maximum, thereafter MP is falling. The shape of MPL or marginal product of labor. And what is the shape of AP? AP also is starts from the point of marginal product. The first unit of labor, what is the amount total product? This also marginal product and average product. So starts from here, increasing, average product is continuously increases, reaches maximum, thereafter average product is starts falling. Now the question arises, what is the shape of AP and MP? What is the shape of average product and marginal product? So this shape indicates inverse of U. Remember, the shape of average product and marginal product is inverse of U. This indicates inverse of U. Initially, so many points we are observing here. The first units of labor, it produces a certain level of output. It is its marginal product and average product. The first unit's marginal product is also average product of the firm. The first point. Next, continuously increasing the units of labor or variable factor, marginal product also increases. It is followed by average product also increases. Okay. Now we write, when MP increases, AP also increases. Now we easily note that marginal product is greater than average product. MP is above and AP is below. That's why we easily write MP is greater than AP. And remember, MP, it reaches maximum first, then AP reaches maximum. This is a maximum point of MP and this is a maximum point of AP. That's why MP reaches maximum first, then AP reaches maximum. And we observe one situation is here, when MP is falling, AP is rising. From this point we states here, when MP is falling, AP is increasing. Okay. And next, when AP is maximum, this is the maximum point of AP. This is the maximum point of AP. Here, the value of AP, it is equal to MP. The value of AP, it is equal to MP. The next point, when AP is falling, MP also falling sufficiently. Now, AP is above, MP is below. That's why we write MP is less than AP. MP is below, AP is above. That's why we write MP is less than AP. Okay. These are the points we are observing here. And one important point is here, MP value is positive, 0 and negative. After intersect, this one is here x-axis. If the MP curve cuts x-axis, here the value of MP is 0. After that also MP become negative. But AP always positive. AP is always positive. It is increasing and decreasing, but never be 0. But MP initially increases, reaches maximum, thereafter falling, then reaches to 0, thereafter it becomes negative. But AP always positive, initially increasing, reaches maximum, thereafter continuously falling. Okay. This indicates, two diagram indicate the shapes of AP and MP. 15 minutes later. The last concept under production, law of returns to scale. Law of returns to scale. This law indicates long run production analysis. Remember, in the long run, two factors, labor and capital, both are varied. In the long run, all the factors are varied, but for the time being, we are considered in our example only two factors, labor and capital. Both the factors are variable. And one important note is here, both the factors are increasing in a same proportion. Both the factors are increasing in the same proportion. The total products are also increasing. In the long run, labor and capital proportionate increases. It results in total product. Total product also increases. But the rate of increase in total product is differ from stage to stage. Initially, total product increases at an increasing rate. Then total product increases at a constant rate. Then total product increases at a diminishing rate. Remember, in all the three stages, we consider as the three stages of law of diminishing, law of return to scale. In the law of return to scale, there are three stages. First one is increasing return to scale. Second one is a constant return to scale, and the third one is a diminishing returns to scale. In all the three stages, both the labor and capital are increased in the same proportion. In the long run, there is no fixed factor also. All the factors are varied. Increasing these variable factors, the total product is continuously increases. Total product continuously increases. But remember, in the short run, total product increases, but after a certain point, total product starts falling. But in the case of return to scale, here total product is continuously increasing. Total product is continuously increasing throughout the operation of the firm. And we know that one important difference between short run and long run, all the factors are varied or not. If all the factors are varied, it is long run. If all the factors are not varied, it is short run. In the long run, all the factors are varied. In the short run, some factors are varied and some factors are fixed. For time being, we are considered only two factors, labor and capital. If capital is fixed, labor is variable, it is short period. If the labor and capital both are changed or variable, it is varying, then it is considered as the long run. In that process, we consider as the production analysis is law of return to scale. The first point here, we states here, CRS, constant returns to scale. Constant return to scale, there is no changes. It means output is increases at a constant rate. Constant return to scale. When a proportionate increase in the inputs, the output increases in the same proportion, it is called constant return to scale. When a proportionate increase in inputs, it results in increase in output by the same proportion is called constant return to scale. For example, 100% increase in input results in 100% increase in output. If we consider 100-fold increase in input, 100-fold increase in output, the same proportion. When the proportionate increase in input, it is equal to the same proportion increasing in output. It is considered as a constant return to scale. Second one is increasing return to scale. First one is constant return to scale. Now second one is increasing return to scale. We states here IRS, increasing return to scale. When a proportionate increase in the inputs, it results in increase in output by a larger proportion. It is called increasing return to scale. Remember, when a proportional increase in input, it results in increase in output by a larger proportion. It is called increase in return to scale. For example, increase in input 100%. Increase in output is a larger proportion. It is considered as 150%. Remember, that is why output is greater than input. Here input and output are equal, constant. Input is 100, output also 100, that is why there is a equal, a constant return to scale. But here increase in input is 100. So same proportion, 100, 100, same proportion increase in input. Output increases more than proportional change in input. That is why output is greater than input, it is a increasing return to scale. When a proportionate increase in input results in increase in output is a larger proportion, it is called increasing return to scale. And the next one is DRS, diminishing return to scale or decreasing return to scale. Remember, when a proportional increase in input results in increase in output at a smaller proportion, it is called diminishing or decreasing return to scale. When a proportional increase in input results in increase in output by a smaller proportion, it is called decreasing return to scale or DRS. It indicates again increase in input 100%, output increases at 75%. It means output is 75% increased, input increased 100%. So 75 is less than 100. So under decrease in return to scale, output increases but less than increase in input. This is a diminishing or decreasing return to scale. So remember, in the first stage, output it is equal to input. In the second stage, output is greater than input. It means in IRS, not second stage, I am stating here IRS, in the increasing return to scale, output is greater than input. And in the third stage, output, it means output increases 75 and input is 100, output is less than input. Okay. So remember, constant return to scale, same proportion, increasing return to scale, higher proportion, and decreasing return to or diminishing return to scale, lesser or smaller proportion. Output increases, output increases, output increases, all the three stages output increases. Output increases at a same proportion, output increases at a larger proportion, output increases at a smaller proportion. This indicates the law of return to scale. Law of return to scale is the long run production analysis or production function analysis. In the long run all the factors are variable, but we states here only two factors, labor and capital, both the factors are variable in the long run. Thank you.